Hi, let us continue. In the previous video, I showed you how do you actually derive the equation of motion of a base excitation system, but we assume tension. Okay, maybe I want to show you what happens if you actually assume compression. Okay, so let me just show back. Okay, so we do the very similar thing. So now we want to assume your K and your C experience compression and see whether we get the same equation of motion. So first of all, as I said, for the free body diagram, we have to draw on the spring and the damper. So because we assume compression, so that means both arrows will be inwards towards the spring and the damper. Okay, so it should be like this. Then only you draw action reaction on the mass. So let's say this is the mass. So you draw action reaction. Okay, so before we write the equation of motion, then we have to determine the relative displacement first. So we need to determine the relative displacement based on the arrowheads. Okay, if you look at this arrowhead, okay, let me just draw again the direction of your X here. Then you also have your base. So your base is also going up. Okay. So you have, if you look at this arrowhead, okay, this side is basically you have to look at the direction of X. So it's opposite. So that's why the damper will get negative X dot, okay, because it's opposite than the X direction. So that one will get negative X as well. So then you look at the other side, which is the side of the base, okay, which is the side of Y. So you look at the arrowhead and the direction of your Y. So it's the same direction. So that means your Y will get positive, same as your Y dot. Okay, the way you write your forces, okay, the action reaction forces, both are the same. It's basically your K Y minus X. So same as your C. Your C you have to write it as Y dot minus X dot. Okay. So from there, then only you can write your equation of motion. Okay, which is actually your equation of motion is based on the these two forces. Okay, there are only these two forces related to your EOM. Okay, so we write the equation. Let's change the color. Okay, so the equation of motion will be both. Basically, if you look at the direction, both are going up. Okay, quite similarly to your X is the same. So you get positive this time. So you write mx double dot. Okay, for M, as I said, it's only affected with X. Y is not affected on M. Okay, so it's equals to, so the direction, the positive direction is based on upwards. So you can see that the forces here, it has the K and the C is also upwards. So you get positive K Y minus X and plus C Y dot minus X dot. Okay, so if you rearrange the equation, okay, you should get mx double dot. Okay, it's negative, but if you want to bring to the other side of the equation, then you may want to change in terms of the arrangement, yeah, which is if I write for the C first, whatever negative here become positive because you bring to the other side of the equation. So you will get x dot minus y dot plus k x minus y. So you can see basically this equation, okay, you want to see this equation here is the same as the one that we have derived previously, okay, which is this one. Okay, maybe you can see. So it's the same. So in other words, basically what I want you to realize that although you assume it as compression or you assume it as tension, it doesn't matter as long as you are consistent with the assumed direction and also how do you derive the relative motion, then at the end of the day you will get the same EOM. Alright, so I guess that's all that I want to share with you. Thank you. Bye.